Today we're going to do some review. We're going to be looking at rearranging and solving equations. This has been done since grade 6, and it's just a matter of being comfortable of moving variables around to isolate the one that you're looking for. And then once we isolate our variables and we've set the formula the way we need to use it, then we can enter our numbers and do the math behind it. So the first thing that you need to do is you need to always identify what it is that you're looking for. In this particular case, we're looking for the value of x. And so we need to isolate everything around it. So currently, the first step that we could do is move away the plus 9. And the way that we look at moving things is always doing the opposite math function. And so when we're talking opposites, we're talking plus and minus, times and divide, something to the square, and the square root. Those are typically the math functions that we're looking at. And so we're going to look at, in order to move the 9, we're going to need to subtract the 9. Because there's an equal sign, we always have to do the same thing to keep the equation balanced. And so we end up with 3x squared is equal to 12 minus 9. And because these are like terms, we can go ahead and solve them. We know that 3x squared then would be equal to 3. Now that we have no other addition or subtraction variables around there, we can look at isolating this particular variable out. And so in order to do that, we would divide, because currently it's 3 times x squared, so we would divide by 3. We would do the same thing to the opposite side. Because these are like terms, meaning that they're both values and not variables, we can go ahead and solve for it. And we're left with x squared is equal to 1. Once we have x squared, the question is asking us to actually solve for x. The opposite math function of x squared is square rooting. Because there's the equal sign, we have to do the same thing. We can solve out, and the square root of 1 is 1. In the beginning of doing all of these rearranging formulas, it is very quite common and acceptable to be doing these in single step motions, but eventually you'll get to a point where you're comfortable and you'll be able to see how you can move things in bigger chunks. In this particular case, we're looking for t, not just t squared, but t. And so one of the very first rules that we do is we always move things out of the denominator. And by things, I mean variables. So in order to move t squared up out of the denominator, we're going to want to multiply by t squared. Again, there's an equal sign, so we're going to multiply by t squared. So we're going to get t squared AC is equal to 4 pi squared r. Now we can look at isolating t squared. Now that it's in the numerator, it's much easier to work with. The opposite math function of multiplication is dividing. So we're going to divide by AC on both sides because we need to keep the system equal. T squared is equal to 4 pi squared r over AC. We need to remove the square because the question is simply asking us for t. In order to do that, we need to do the square root. We need to keep the system balanced, and so we have to do the same thing to both sides. So t is equal to the square root of 4 pi squared r over AC. When we are solving for a variable where there is addition or subtraction, in this particular case it's asking us to solve for initial velocity, we always move the additive or subtractive piece first, and we can move the entire chunk. So we need to start shifting our way of looking at problems in that we can move this entire chunk. The opposite math function is to subtract 1/2 AT squared. We're going to do the same thing to both sides to keep it equal. So we're going to have d minus 1/2 at squared is equal to vi t. Now that we've done that, we can remove the t so that we can isolate for the vi. Divide by t. When we divide this side by t, we need to divide the entire piece by t. d minus 1/2 at squared divided by t is equal to vi. One of the things to pay attention to is that you cannot think that you can just cross this off and cross one of those off. That doesn't happen. Because we have this subtraction sign in here, if we were to rewrite this, this actually looks like d over t minus 1/2 at squared over t is equal to vi. So even at that point, then we could cross this off, but you would see that there's still a t in the denominator. So it's just easier to leave it just as this final point here than to remember to take it down to this step here, okay? All right, you're going to move on to page 9 of your question packet and work on question number 1. And then on the reverse side of this sheet are a bunch of practice questions. I encourage you to do these first. If you have any questions, please make sure that you're coming to me for help. I'm available Wednesdays and Thursdays at lunchtime. A quick note for a question like this, or a question like this, where it involves brackets, you need to move all of the stuff around the bracket first. And so for this particular example, 2 is in the denominator, and so we go with that rule where we take everything out of the denominator first. And in order to do that, if we were looking at this particular question, we would multiply this side by 2 and multiply this side by 2. And so you would have 2d is equal to vi plus vf multiplied by t. We still cannot remove these parentheses because we need to add in our velocities first and then take that value and multiply it by t. And there's a reason why we follow this particular rules, because anything inside of the brackets will raise or lower the value faster than anything to an exponent, anything that's being divided or multiplied, or anything that's being added and subtracted. And so we need to do this piece first, and then we can move on to the multiplication. So we have to move the t first, and by doing that, we divide the whole system by t. So now you're left with 2d over t is equal to vi plus vf. Once we remove this t, these brackets will fall away and open up this equation. Now we can isolate for vi by moving vf. The opposite math function is subtracted. What we need to pay attention to is that this 2d minus t is one whole piece minus vf equals vi. The common error in a situation like this is to go 2d minus vf all divided by t, and that will give you a substantially different value. So make sure that if you're moving something over that's already got a multiplication or division system in place, that you isolate this piece together and then do your subtraction or addition.